Chain rule with and different, yeah. Chain rule, no, it's one of those things, kind of like the equation of the tan line. Chain rule never goes away now. Once you learn something in here, it just never goes away, unfortunately. All right. As much as you wish it would sometimes. Okay, that is the one exception, that will be in Unit 1 and our Unit 2, and then, I mean, it'll show up randomly, but it never applies again. 3. 3 of 8. That's pretty good. And we're still in the first quarter, yeah. The plan is that we finish everything with a minimum of 8 weeks to spare before the exam. Preferably 9. All right. A whole quarter what? Well, and the exam's early, so then, like, we literally sit here during those 8 weeks, and it is self-paced. Yeah. All right. What? Yes, you are, Noah. Yes, you are. Yes, you are. Yes, you are. 1 through 12, give me a question. 4, excuse me, Miss Attitude. All right. X squared equals x minus y over x plus y. I just started taking derivatives. Oh, no, you did the quick review, didn't you? You did the quick review? 3.2? You ate it up because you've done it before. One. That was easy. All right. The left side, what's the derivative of x squared? 2x. Now on the right side, I've got a fraction, so I'm either going to have to use, I was wondering what happened to it. I either have, what? You didn't like the fraction? Okay, so if you don't like the fraction, I tend to not like the fractions either. And I was telling somebody about this, I can't remember who, but I always change mine and do product rule. I do this and do product rule. But it doesn't matter. You can do whichever. If you'd rather do quotient, do quotient. If you'd rather do product, do product. Yeah. You could. So what you did, you could. Like that. So you get x to the third plus x squared y equals x minus y. You could. That might even be easier. Somewhere. Is that what they did? They did quotient rule. So yeah, either way is fine. Whatever. There's always more than one way to do it. If you can manipulate in the beginning, a lot of times it's a lot easier. There's actually paper on a roll somewhere. But I'm also hesitant sometimes with that because it leaves you more room to mess up in the beginning. So if you mess up on your algebra in the beginning, then you've messed up your problem all the way through. So whatever way you choose to do it, we'll just do it as it sits and do quotient rule because if I had to guess, that's the way most of you did this one. Huh? Product? What did y'all do? Quotient? I'm gonna do quotient, and then I'm sorry. Let me take all this off. If you did all that, it's not wrong. So derivative of the top would be 1 minus other way, dy dx. That's okay. Times the bottom. Yeah. No, it's not. There's not explicit differentiation. Nothing's explicit in here. And then the top times derivative of the bottom, which would be 1 plus dy dx over the bottom squared. Yes, no, maybe so? Remember the goal? The goal here is to get dy dx by itself. Yes? So I'm probably going to now move this over to the other side by multiplying. Cross out one of what? No, because you kill a kitten. And you kill a kitten because that subtraction sign's not in parentheses. All right. I think to get dy dx by itself, I'm going to have to FOIL out the top. I don't see any other way. So what y'all did? X plus y minus x dy dx minus y dy dx minus, and I'm subtracting all of this, so I'll put it in parentheses so you can see x plus x dy dx minus y minus y. This, I feel like implicit differentiation always looks worse than what it is, because at the end of the day, there's not always a lot of simplification that comes with the implicit differentiation. We're just getting dy dx by itself. Okay, so in other words, I don't have to FOIL this out. I don't have to multiply by 2x. I just need to work over here and factor it out and get dy dx by itself. So do I have any like terms? All right, you said yes, this does cancel. That's subtracting. Is that it? The x's cancel as well. Okay. So we've got negative 2y's. That takes care of those. And we've got minus 2x dy dx. What's positive? Yep. Oh, well, that worked out nicely. Move the 2y. And then what? Divide by negative 2x. And I just have to write it. Now, don't cancel this out. Don't cancel this 2x and this 2x because of that subtraction sign there. I would tend to leave it just like that. They probably FOILed it out once you simplified, did it? Remember when we did rational fractions and we said until everything's fully factored top and bottom, you're not done? That's probably what they're doing. I would say that's a little much work on that one. So 2 from everybody? Could do that too. Only it's necessary, but you could. What else? 7? Yeah, it's like a yeah. All right, derivative of the left. Derivative of x is 1. What's derivative of tangent? Secant squared. All right, so remember, power, trig, argument. There is no power, so I move on to trig, so secant squared, but all of this has to stay the same, yes? Then I multiply by the chain, which is the derivative of the inside here. So product, it has to be product rule, that's right. So I have to do derivative of the first, which is 1, right, times the second, plus the first times derivative of the second. Derivative of 0, 0. Subtract the 1. Remember what I'm trying to get on its own, and it's the dy dx. Yeah. You can if you want to. Secant squared xy times y plus x dy dx. I'm just moving that negative 1. If you could see this in less steps, that's fine. I just wanted you to see where this was coming from. I moved the 1 first because otherwise I'm going to have to distribute this through, right? And I don't want to do all that. What I'd rather do is just divide both sides by that secant squared. And so I get y plus x dy dx plus negative 1 over squared xy. Subtract the y. Again, if you can see this all together. Divide by x. I might even, instead of dividing by x, I might just write that and be done with it. or divide both of them by x, whatever you want to do. I don't like to mess around and start getting my argument with the trig part mixed up with my denominator here. So, what? That isn't wrong? You sure? 11. I heard 11. At the point 3, 4. Find dy dx and the slope of the curve at the indicated point. So the first thing I'm going to do is go through dy dx, and then I will plug in this x and this y value. So this is a chain rule one, right? I'm going to do power, and then I have to chain it. In this case, the chain derivative of x is just 1, right? So that's pretty easy. And then derivative of the second part, but what's the derivative of y minus 1? Y dx. Y dx. And the derivative of 13 is? Can you solve that for dy dx now? Yes, I hope you can anyway. I've got 2y minus 1 dy dx. Say that again. Not product rule, but chain. Yeah, just change it. Just change it. So dy dx equals negative 2x minus 1 over 2y minus 1. Of course, these 2's can cancel, which is going to make my life a little bit easier since I have to evaluate this one. It says find the derivative then at 3, 4. So dy dx at the point 3, 4 would be x is 3, y is 4. 3 minus 1 is 2, so I got negative 2 over 3. Describe for me what I just found. Slope of the tan line on the curve at the point 3, 4. What kind of curve am I talking about? Curve? What's my graph look like? Look at your green function. A circle. It's a circle. So what I've done, I've got this circle at the point 3, 4, wherever that is. The slope, if this is 3, 4, the slope of this line is negative 2/3. That's what I found. What if I needed to write the equation of the tan line at that point? That's exactly right. So y minus 4 equals slope. That's right. Still doing the same thing over and over and over and over again. Finding slope, the slope of what? The slope of the tan line. How do I find the slope of the tan line? By finding the derivative. How do I find the derivative? Where I might have to use the product rule or the quotient rule, or I might have to chain it, or I might have to do implicit differentiation, but it's all the same thing. Does that make sense? Yeah. Okay. What else? Anything? What? Twice. Do 12.
Oh, no, we did 12 of them.
Okay. He's not. He's not. On this what?
It's a lot at Walmart. We saw him and he gave us a fist bump and he was wearing like a tank top and the arms were like all the way down. He'll be here at like 9.
Tell me where this graph is differentiable. Or I tell you what, tell me where the slope is defined. Which means where is it differentiable? Okay, so if we can find where it's not differentiable, we can just leave that out. So how are you going to find where it's not differentiable? And not using a calculator or a graph. Find the derivative. Since there's a y in here multiple times like this, I'm going to find dy dx. Did you say that? Did I say that? I'm sorry. Speak up so I can. Oh, Dozier said it. Did you say it, Dozier? Good. Find the derivative. All right, derivative of the first. I know. I'm getting the death glare. I'm used to it. All right. Derivative of the first would be 2x times the second plus the first. Oh. Derivative of, I'm doing product rule.
I don't know the rules. I just do it.
I just follow my heart. So if I'm multiplying, I need to use product rule. I'm 100% sure. dy dx. Okay, so look, Sullivan, for this second one. You see, I can split up the first piece from the second piece because there's a subtraction sign, right? But because I'm multiplying these two, I'm going to have to split it up with product rule. Yeah.
We're doing 2x squared. Oh, I'm sorry, I'm looking wrong.
Oh. No, that's okay. That's all right.
So that first thing right there is just the first.
That's just the first one. That's all right. Look. Remember, it's like UV, so derivative of the first times the second plus the first times derivative of the second. What is going on right now? Yes. That's right. 1y squared. You don't have to know. Yep, 2y, dy dx. Perfect. All right, so because it's y squared, I had to do power rule, but anytime I take the derivative of y, I always follow with a dy dx. Wait till we add the third and fourth variable in here. Okay. So now I just get dy dx by itself. Okay. So just so you see, and if you don't need to write this step, that is a-okay. I am just going to show you how this minus sign is distributing through here, right? Because I'm subtracting everything in that second. So now what I'm going to do is I'm going to move everything that doesn't have a dy dx on it, yes? Okay, so I'm going to move that all over to the left side. So on the, to the right side. So on the left side, I end up with x squared dy dx minus 2xy dy dx equals y squared minus 2xy. If you put it the other way around, that's fine. I just like mine. Yeah, I don't like my negatives. Now what? Take out a dy dx, right? So if I factor out dy dx, it leaves me with x squared minus 2xy equals y squared minus 2xy. Now what? Divide by that whole parentheses, right? Tell me how we are filling up to this point with implicit differentiation. If you just have a straightforward equation like this, find dy dx. Yeah? 8 times out of 10.
I'd say
Yeah.
like 7 out of 9.
No, because I'm subtracting there. If I was multiplying, yes, I could, but I can't just cancel them out because silicate. Oh, you never. How do you never knew what we were referencing when we said that? She said, "Why do y'all keep saying we're killing a kitten? Where's that from?"
Well, like, why?
You said that for like 3 years.
I heard it.
All right. So if I want to know where is it not differentiable, well, it's not going to be differentiable where this is 0. That's right, because I can never have the bottom go to 0. So how in the world am I going to find out where that happens? Okay. Set it equal to 0. Then what? I want to know, think about this. If I can find out what x is to make that 0, I can find the other half of the puzzle, which is the y part. So figure out an x. Yeah. Solving for x. So I know at x equals 0, I am not defined, right? And then this one is a little bit harder. X equals what?
I like that.
Think about this for just a minute. What did my original equation? Okay, so you don't know what that shape is. You probably should, because you should have gotten to it in geometry, but whatever. This one's not a circle. This is actually a hyperbola, I believe. Hyperbola. Doesn't matter. Look, here's the point here. If I solve this actually for y, because I've got a whole equation here, this is a line. Actually, not a line. This is one of these guys. Right? No. This is every point where it's not defined. Okay, so either way, I would be okay. I would say leave it here. I was just looking at your book. Your book solves it for y, but I wouldn't. Sorry. So it is a line. We're finding where is the function not differentiable. The function not differentiable when the bottom goes to 0, when the derivative of the bottom goes to 0, because I can't have a 0 in the bottom. That whole line, anything on that line would be not differentiable. But what I don't need to show the line. I just need to show when x equals 0, I'm not differentiable. When x equals 2y, again, I'm not differentiable. I just need the equation. But the point is, do you see the technique we used here and what we did? Find the derivative, set the bottom to 0 to find where it's undefined. Does that make sense? Okay. Let's keep kicking it then. No, slave, silly goose. $13. That is a pie indeed. Find the tan line and the normal line to the curve and open. And a normal. Mark that go. Whoa there. Tan line and normal at the point 1 pi over 2. You should be able to do this. Say that again. Yeah, that's 2x times y. Yeah. Find the tan line at the point 1 pi over 2, and then find a normal line at the point 1. Oh my goodness. What do you need to write the equation of a line? A point and a slope. What do you have? What do you need? How do you find a slope? Derivative. False. All right, I've got the point. I need the slope. Yes. Let's find the slope. This another word for slope is, or another symbol for slope, dy dx. So let's find it. What? All right. Slope first. Derivative of 2xy. Derivative of the first times the second plus the first times derivative of the second. Anybody confused? Speak now, forever hold your peace. Plus, I'm just starting, yeah. Do I need to do the product rule on pi sine y? No, why? I will have to do chain rule. You're exactly right. Why don't I need product rule here, though? It's a coefficient. It just represents a number that never changes. It's a variable that doesn't vary. It's the same all the time. So I always treat it as a constant, right? All right, so pi, I don't have a power, so I move on to the trig. What's the derivative of sine? Cosine, and I leave the inside alone, but now I take the derivative of the inside. So why it's right, this is a chain, right? What's the derivative of y? Dy dx. This sits outside the cosine, right? This is times all this. Okay, equals, what's the derivative of 2 pi? 0. Why is it 0? Pi is a constant. Remember, if it's a constant, the derivative is 0. It always represents the same value. It's always 3.1415. Okay? Yeah. If it's a constant, yes. But if it's a variable, you have to do product rule. So like if this had been an x in front, then I'd have to split it up and do derivative first times the second plus the first. But because it's just that constant, I treat it just like a coefficient. So if you had the derivative of 3x squared, you do 3 times, what's the derivative of x squared? 2x, which gives 6x, right? So if it's a constant, I can just kind of pull it outside and keep it hooked. I don't even remember. It's busy.
Oh, wow.
Busy.
Now tell us what you did.
Cake. Yeah, it is right. Cake. I baked all day Saturday. All right. I was at church. All right, so I want to get dy dx by itself, so I'm going to move the 2y first. I might eat, well, I'll keep it like this. Oops. Why? What's awful about it? This is the only calculus I've done. Me too, I'm tired. All right. I'm going to factor the dy dx out. Yes? What's left? 2x plus, there you go. There you go. Nope. All right. Do not lose track of what it is we're doing. We're trying to write the equation of the tan line. These are those problems that just take forever. That's right, it's the slope. The point of all this was finding the slope. I've got an equation for the slope, but to find what that actual slope is, I need to plug in. That's right. So I don't even remember what my point was. 1 pi over 2. So the derivative at 1 pi over 2. This is my x, this is my y. Plug it in. Negative 2 times, hold on. Oh, sorry. That's an equation for my slope. That's the slope of the line anywhere I go. But I can plug in any x and y I want once I have the equation. So this is an equation for slope anywhere. Since it's the cosine and it's a pi over 2, I'm going to go with yes. This would be a non-calculator problem. Well, let's look at it. The 2's cancel. I got negative pi up top. I got 2 plus pi. What is the cosine of pi over 2? I'm up top of the circle. 0. 0, because the x value is 0 there, right? So it's just negative pi over 2. What have I just found? The slope of the tan line at the point 1 pi over 2, right? Now, to write the equation of a tan line, you told me I need a point and a slope. I was given the point. I just found the slope.
Now write it.
Write it. Point. Point. Slope. Y minus pi over 2 equals, done. You can solve it for y if you like. Logan's going to show us the normal line. Pink, I feel like y'all can't see that too well. That's not much better. All I have to do is flip that slope around here. The normal line does? That, don't say that. What'd you say? Is 2 over pi the same as what? Oh, sorry. I did not hear that, and I'm glad I didn't. Same song and dance. Go. Yep.
I have to write something like outlandish on my ass.
I'm committing wherever no one else is. You going to Central? Wherever you go. Because I'm really out. USC not on their
tan and normal lines. Looking through this derivative here, and I'm probably going to stop at the derivative and let you fill in the tan line and the normal line because I got one more example that I definitely want to show you before. Yes. Say again. Yes. All right. Derivative of the first times the second. If you don't have to write the one, that's fine. I find sometimes it helps me whenever I'm doing products so that I can follow my work. Plus the first times, all right, here I go. Derivative of the second. No power, so I move on to trig. So cosine and leave that inside alone. And now chain it. 2 dy. Yeah. Because x is not a constant. X varies. Pi never varies. All right. Second piece over here. Derivative of the first was 1 dy dx, right? So yes, it's 1, but I need to follow it with dy dx since I took the derivative of y times the second plus the first times derivative of the second. Negative sine. Now chain it. This one's yes. So what I would probably do, I would probably clean this one up just a little bit before I solved it for dy dx. I would probably make this one 2x dy dx cosine 2y. Remember, multiplication is commutative, so I can do it in any order, and sometimes it helps me to see it in a different order. Equals, okay, so this one's pretty straightforward. Minus, because of that negative, and I'm going to do the same thing, 2y sine 2x. Which x on the outside? X times this one, I put it here. There's not, this is multiply, not add. You can do this. You can do this. Look, this is just manipulating equations is all at this point. This looks awful, but at the end of the day, the hardest part about this is moving the algebraic equation around. It's not the calculus, because this is the calculus, is the product rule and the derivative and stuff. That's not hard. The hard part is getting that piece by itself. Who is that? Oh, really? No. All right, so I'm going to assume at this point, can you get it by itself, or do I need to keep going? Okay, I'm going to move this one over here, and I'm going to move this one over here. Why am I doing that? I need to get all the dy dx terms on one side and everything else on the other. So I have 2x dy dx cosine 2y. Now I'm moving this one over because so I'm subtracting. Dy dx cosine 2x. Please what? Yes. Tell me when you're caught up. What? What? I thought you said guess what? What? Guess? I thought you said guess what? And you said yes what? She said, will you please slow down? And I said yes. All right, now I am going to move this sine 2y. So I already have negative 2y sine 2x minus sine 2y. It's just nasty. It just looks terrible. You were visiting in Italy 2 years ago. I'm going to factor out a dy dx. Don't. That's like, turn around. You'll get it in a minute. Give it a second.
I like that.
Is this a morale crusher? Yes. Oh, you would still, but I'm going to stop there because I figure you can plug it in at this point. I want to have